very much for being here today. And thank you very much, Bob. That was a very good presentation. I think it's important for us to understand about spectrum. And spectrum is the key to deploying private networks. We have to understand it in a point of view that obviously private networks have to have a purpose. The purpose is that we're seeing challenges that utilities are facing. And these challenges are really something related to not only technology, obsolescence of the actual technology that we have there in the field. And when I say we, I used to work for a utility for about 10 years. I used to be part of Oklahoma Gas and Electric. I used to do networking architecture and security architecture. That's when I was hired by Nokia in order to support this segment. So what I brought was the knowledge of the actual challenges that utilities have. So as you can see from the WAN requirements, we're seeing all kinds of different types of networks that are being deployed, single-purpose networks. When we first deployed at OG&E AMI and field area networks with DA, that was back in 2010, so basically a long time ago. Every single network was devoted for a very specific purpose. We had our AMI that was running on a WiMAX network, and we had our DA that was running on 900 megahertz on license. And it was working great. And then more and more applications started popping up. We had to manage the traditional SCADA stuff. We had to manage all of the gas side of the SCADA. And that was just a really difficult thing to do as we were really stretching our resources thin, the number of people. We're seeing now more and more intelligent applications coming to the actual smart grid. So it's becoming smarter, right? So we have synchrophasers, for example. Some devices that actually are doing protection at the grid level. So the protection was normally transmission. Now we're seeing a lot of applications doing actual teleprotection at the grid level. We're seeing DERs. I was having a conversation the other day with somebody from EPRI discussing about islanding problems that we have with DER sources and how are we going to do that, how we're going to handle that. Well, all of those use cases require connectivity. Without connectivity and without really reliable and low latency connectivity for certain use cases, becomes an issue on how we're going to handle that. It used to be that utilities were a top-down model. You generate it, you went to transmission, you distribute it. Now you become a broker. We're seeing more and more utilities that are having to deal with individuals that have their own wind farms or their own solar farms, and now they have to basically accommodate all that spare capacity into their network. And sometimes they're forced by legislation. So all of those challenges really do come and define what are the new use cases that are needed. So this is just a brief summary of what we've seen from a Nokia perspective of all the use cases that are being required in a network. So now all these people in the utility have to meet all these requirements. Well, great. I mean, some of these applications are really cool. Drones, for example. I'm going to use an example. We actually did drones at 700 megahertz for a utility in the Northeast. It was great. It worked awesome. I wish everybody had that band, right? Not everybody has. And even the utility that tested that spectrum band is not going that because of the price of the spectrum. That's something I'm going to come back to. But what I was saying, there are certain spectrum bands that are so great that are unachievable because they just cost too much, right? At least for a utility perspective. Sometimes we, and the people that I work with, because there's carriers and there's other people working in telecommunications, they forget that the core of the business of a utility is not communication. They look at all this really great equipment, this great technology that's coming out, and well, it's great for a carrier if you're talking about services and you're going to be monetizing. So they're okay paying up to $88 billion for spectrum. Yes, $88 billion for C-band. That's right on top of CBRS. And not only that band has challenges, they actually, Bob was talking about a band that has some problems with satellite and GPS, but also they have problems with AT&T and Verizon with the airplanes. So the FAA is saying, you cannot turn on that band. So they paid all that much money for that. The issue is that that is the crux of like I'm saying, their use case is completely justified because they're going to be monetizing that. In the case of utilities, we can't. We need to focus on these use cases, however. And we need to focus on those use cases in order to build one single infrastructure that takes away that headache of having multiple networks that were single purpose, right? We also need to understand that our people, the ones that are running our networks, are starting to basically getting ready for retirement. And we have a new set of mindset that is coming from these young people coming in the utilities in a little bit of clash with the older culture, that are trying new ideas, and they're saying, oh, why don't we go with the technology that we use in our hands every day, phones, for example. So that's one of the things that we're driving at moving forward with newer technology. We talked about 4G, we talked about 5G, we talked about narrowband IoT. Well, let's really clear up the air. What's 4G? Are we really going to 5G? What does 5G really bring you? What does it really mean? Well, if you look at those use cases that we just talked, they really are different from the type of use cases that we normally use on our phones. Netflix and WhatsApp and all the kinds of FaceTime, all those issues, right? All those applications, I should say, they take a lot of bandwidth. However, when you really look at industrial applications, we really are interested more in latency, the number of devices, and especially reliability. And that's where commercial networks really don't meet the new use cases, because unfortunately they're not really reliable. Well, we can handle that when we're talking with somebody and says, I cannot hear you, can you move a little closer where you have better signal? You cannot ask a recloser to do that. You cannot ask this interfacer, hey, can you move a little closer, or what's happening today, right? When I was at utility, 80% of the time is what we had uptime, right? For cellular networks. That was one of the main issues why they said, oh, okay, our leadership said, oh, we have to do our own stuff because we cannot rely on this. Not even 1.9, not even close to 1.9. Is it 8, actually, right? So all of those things are actually very important in order to understand what we have now and what does 5G bring us. Well, if you really want your phone at blazing speeds, then obviously 4G is not necessarily the technology. But if you look at what we can do with 4G, LTE Advanced Pro, really what it's called, or some people call it 4.9G, right? Because don't forget that LTE has been a technology that has been developed for the last 20 years, 22 years now. It started in 2000, right? And that was LTE. And from there were many versions. They were all called releases. And that's what we're seeing on the bottom part of the slide. Those releases are the ones that define the features for the newer technology that's coming out. And so LTE stopped at release 15, and that's when 5G came on board. The last version of LTE was called LTE Advanced Pro. And as you can see on the left side, there's actually the capacity of going down 1.5 gigabits per second on the downlink and up to 300 megabits per second on the uplink. Wow, we didn't know that you could do that with LTE, right? The only thing is 5G. No, 5G can do 10 gigabits per second, in theory. But let's look at the other things that we're doing. We're doing the sensor, we're doing machine-to-machine communications. I mean, we were the ones who truly invented IoT in the utility world. We didn't call it IoT. We just thought we need to have the closers talking to us, right? Talking to one, to another, or talking to ADMS. That's IoT. And that's our core of the business. So that is where we still can support it. Because now IoT and the sensors are really covered by 4.9 without any problem. Machine-to-machine communication, right? We have mirror bits. We have that application from XCL. That's great, we can do it over LTE. Yeah, that's machine-to-machine talking. Right? It's not this car-to-car talking, but it's something we do. So do we really need to go to 5G? I think that the technology is going to wait for another maybe 10 to 15 years before LTE really is shut down. Heck, we still have 2G networks we're supporting for transportation systems in Europe. So think about it. I think that's the benefit about having a network or a technology that's defined by 3GPP, because you define those standards that are backwards compatible, and you actually create the capacity to have new features moving to the right, while still maintaining the old features going back to the left, all the way back. It's important that this is an ongoing definition. 5G officially still hasn't been completed. The actual details of 5G will be completed in release 18 in 2023, somewhere around October, maybe. We just had one release completed this year, release 17, and that's why everybody's so excited about RedCap, which is the evolution of narrowband IoT, which 700 MHz could probably do. But, well, that's going to take a while for the industry to catch up to that. Usually it takes about a year to a year and a half for the industry to actually bring that technology to reality. So it's important to understand that we are still moving in an evolving environment for 5G, and that's where we really, from a technology perspective, have to look at what the features is that we're bringing, but then the reality. Reality is spectrum availability. Because no matter how great the technology is, you're bound for what you can do. It's like having a great router with 100,000 gigabits per second on the cable, but you only have a cable that does 10 megabits per second, right? So you cannot do anything more than what a cable can do. Same thing with spectrum. And it actually is one of the things that technology is pushing, but you really have to understand the business drivers that are driving them to the definition of spectrum and what's available for it. So really into looking at the use cases, and we look at the actual capacity that's needed, bandwidth, the actual latency that's required, if you're going to provide quality of service. Now that's a very important feature because in the past, you had a whole network to yourself. You had a DA network, you had an AMI network, right? So no matter what you did, you had whatever you had in that network. Now with LTE, you're looking at a network that supports multiple services. And those multiple services are going to be defined based on not only how much is available, spectrum, and how much that prioritization has to be important to the utility based on how critical that application is to. So mission critical applications will require quality of service, whereas other applications may not so. And this is just an approximation of the actual use cases that we see utilities deploying with a variety of different types of requirements from a network perspective. As you can see, bandwidth, I purposely chose not to include the bandwidth because it changed from 9.6 kilobits per second all the way to 50 megabits per second. That's a huge variation, right? So I'm just going to use low, medium, and high. You can fit the use case somewhere there because depending on how much your DA people want to pull and how much they want to basically look at the security video camera from the substation at 4K, I don't know for what purpose, but they could, the bandwidth changes. And so it's important to understand probably how you can create prioritization based on these requirements. Again, this is just a sample. And that's why it's important to understand the quality of service and then how you're going to fit that within the spectrum bands that Bob mentioned. There's plenty of different use cases where you can put in them there, but not all of them are going to fit. And that's the reality we need to face, is that when we're deploying a network and we're evaluating our spectrum options, we really need to understand how much of the actual use cases we can fit, and whether we really require bandwidth or we really require prioritization. Do we have enough assets to cover our service territory, or do we need to install new assets? One of the points that Bob was making about CBRX, for example, which is one of those bands that is like a lot of people are wanting to it because it's free. I mean, you have to pay a nominal fee for using it, but it's the fact that it has a lot of bandwidth available. You look at other options that are more constrained, say the new band that the guy was bringing, for example, is just 5 megahertz, right? It's great, but it's just 5 megahertz. So there's so much you can put in there. And Terex's band is 6 megahertz, 3 up, 3 down. Well, it's great band, it propagates very well, but it also has limitations. So you cannot just put all of these things into one single network. So what we see is that utilities are looking at hybrid deployments, like Bob was talking about. What he calls duet in the industry we know as headnets, heterogeneous networks, where we are really mixing bands depending on where we need the use case and where we can be surgical to meet those requirements. The key there is the actual technology underlying that, all the networking components are the same. You are deploying one single network and you are putting different radios up in the towers and in different locations, but you're not changing the architecture of your network overall. You're defining a single homogeneous quality of service scheme that is going to cover everything. You're managing everything through IP, and you're covering one single technology, which is very important. Going back to what I mentioned before about single-purpose networks. So that is where we really need to look into the spectrum, and that's why it's so important. As Bob was mentioning, there's a couple of bands that were not mentioned. One of the ones that we've been working, we've seen utilities deploy, especially for offshore wind farms, is band 53. That's in the 2.4 gigahertz. For onshore applications, we normally don't see it just like the band 24 from the Gato because it's low power. It used to be a former satellite band, so in order to transmit, because there's still some satellite applications next to it and other general purpose applications below it, as you can see, there is actually a limit of how much total power you can transmit, which really reduces the usability of that band. But we've seen it that for offshore wind farms, for example, there's no restriction. So it's very important to see that. Another band that's coming up, it's actually LTE on an unlicensed band.
This is where you deploy LTE without paying anybody anything, well, except for the vendor, right? Us in this case, where you can deploy alongside of your Wi-Fi deployments. LTE on a licensed band is a concept that was actually evolving, and it was now basically ratified by 3GPP, and this is part of an alliance that was started by Qualcomm and other vendors, including Nokia, that really is trying to bring a technology that really supports mission-critical applications a little better than Wi-Fi, but with the able or capacity to coexist with Wi-Fi. It used to be license-assisted spectrum LAA that you could use using a licensed band, but that required a licensed carrier. Well, with Multifier, you don't have to do that anymore. And not only that, but also, like I said before, you can deploy it safely with Wi-Fi. So that's another band that you can look at, from all the options that Bob mentioned that are now available. Because right now, to be honest, in the utility world, we need as much options as possible because we are constrained. And that's one of the things that probably somebody's going to be able to do at the legislative level sometime. And we rely on guys like Bob to do that. So going back to having the options to deploy and trying to deploy without having to pay a pretty penny, we've seen a lot of actual utilities go for PAL licenses. There's been a couple of utilities in the West Coast, one particularly that paid significant amount of money on this band, primarily because they really want to make sure that they have something that they can transmit. Others that were not so lucky that they either couldn't make the cut on the time or the actual money that was readily there, well, they're going to have to rely now on a secondary market. And I think that's one of the important things is that once you've gone through the PAL licenses and the options, there is the possibility, and the FCC is creating the secondary market. And I think Bob is his company is actually one of the brokers that's going to allow for some of those licenses to be released or resold, and I don't know what the rules are going to be, to utilities that couldn't make the cut the first time. But it's important to understand, and this is the weakness of CBRS, and that's why we look at this in a way in which it's great, but it's not so great, that is shared spectrum. If you have a PAL license, well, great, you're going to have priority to get to where you want to go. If you don't have one and you are a GAA, well, you're just going to have to take whatever you get if it's available. In a lot of cases, we haven't seen any problems with people getting this. But there are certain areas that actually do have limitations. And those limitations are the actual exclusion zones. So you can see part of that slide here. And those exclusion zones are because the military has access to a large part of that band. That band is 150 megahertz, which 100 megahertz of it can be used by the military or other special incumbents. So when they are in town, you're supposed to shut down. No matter how mission critical your application is, no matter how many PAL licenses you have, you're still gonna have to shut down. And everybody is going to try to go to the upper 50 megahertz, the former WiMAX spectrum, and then you're gonna have the former WiMAX issues, interference, right? I remember at OG&E we deployed WiMAX, it was great, but we had so many issues in the rural areas in Oklahoma because of the WISPs. So I think it's important to understand the limitations and the existence of the SAS. So the SAS not only allows you to get a band so that you don't interfere with everybody else, but also will tell you to shut down when the incumbents come. Domain proxies are trying to be a solution for that, in the sense that, well, they're probably going to still allow you to transmit before you shut down because they can get a specific way of operating. And there is a 24-hour period between each grant renewal process within CBRS, meaning you don't get one grant and you have it for life. You get one grant and you have to renew it every day, right? Or you lose it if you don't respond back to the SAS after 5 minutes. But these grants do have a period, and these grants are actually renewed every 24 hours between all the SASs. So there is a chance that if you have a domain proxy, you can maintain connectivity for whatever it's left until that time of the negotiation between the proxies. So that's what a lot of utilities are doing now, are looking when they're deploying this. But obviously it's not the solution. So we go back to do it. We go back to looking at different bands that are available. Some of them that are licensed that are not necessarily going to be deployed everywhere, whereas CBRS is probably going to be deploying the areas that it's not really economically worth for the utility to pay for the licenses. So that's what we see now. And well, I think that's really the meat of the discussion I wanted to talk about spectrum. This is the marketing part. We do have solutions that actually work on all those bands. So we have a solution that is flexible, that's like a Wi-Fi replacement. And we also have the customized solution that can scale up to millions of devices. We've seen requirements from utilities that they want to deploy sensors of all kinds, making their footprint in the millions of devices in the network. And I know that that number, just when they asked me the first time, and probably you guys are saying, millions? Yes, millions. They are not necessarily your traditional communication devices, they're more like sensors, but that's what we're seeing nowadays. And that's where you start looking at the requirement for that. So we have all the actual hardware that supports the core, we'll have all the hardware that supports all the bands that have been mentioned here. And yes, we're working with Legato on the newer band, not only working with them on the 3GPP standardization process, as we're working for making band 8 in the US a 5G band. 5G requires at least 5 megahertz of spectrum. And right now, and that's uplink and downlink, so minimum of 10 megahertz. Altogether, if it's FDD, we're working with the 3GPP to make 3 megahertz available as a 5G band as part of Release 18. And that will benefit, in this case, the likes of Anterix here in the US that only have access to 3 megahertz. And in other parts of the world, for example, the 450 megahertz band in Europe, that actually they only have 3 megahertz as well, that is only LTE right now. And with that, I don't know if you guys have any questions